Yeah, g'day, it's Charlie, ZL2CTM. Well, I had the opportunity this morning to solder up the audio frequency amplifier, which I just wanted to sort of cover off briefly today as we continue building the various stages for this particular radio. So you recall that I was looking to have an overall gain across the stage of 40 dB, and that's going to be made up of 34 dB, which is a fixed gain of the LM380 plus another 6 dB coming from the NE5534. So 34 plus 6 gives me a total of 40, and that's exactly what I'm seeing, which is good. So the two stages there. Input stage is the 5534 low noise amplifier, low noise op amp I should say. That's configured there as an inverting amplifier. So our voltage gain is minus RF, our feedback resistor, over Rin, our input resistor there. So I've got a 200 ohm trim pot there to give me the ability to vary the gain from less than 2 to approximately 4. So 200 divided by 51 is approximately 4, but I'll have that for a starter set at around 100 ohms, so 100 divided by 50 gives me that voltage gain of 2, and 20 log 2 is 6 dB. The inverting, say again the non-inverting input, pin 3 here, I've got sitting at half VCC using two 10k ohm resistors. Reasonably high there to minimise the current flowing through there, but also to minimise any noise that might be produced across that particular resistor there. Bypass to earth using a 10 microfarad capacitor. Yes, so for this particular configuration here, the input resistance looking into this device is Rin, which is 51 ohms, which will be presented to the upstream components. Right, so the output of that first stage goes to the 10k ohm volume control, and the wiper arm then goes into our fixed amplifier stage there of the LM380. Basically straight out of, or pretty close to straight out of the, what am I saying, the data sheet for that particular device. Nothing too much to say really. Decided to go up to 470 microfarads for the output capacitor. Just a note too that in this particular device here, pins 3, 4 and 5 and 10, 11, 12, which is the center 3 on either side of that device, are set to ground, but they're also used as a heatsink. In my experience, and it's certainly the case in this one, at full volume, at a volume which is too loud for me to actually listen to the speaker, I'm not getting an overheating issue with that particular device. If I was, then I would look to solder using a little sheet of copper directly onto those particular pins on either side to provide a bit of a heatsink. But at this stage, I'm not having an issue, so I don't intend to do that. So, sort of zooming out a little bit here, we have coming in off the SIGGEN up there a sweep, a signal that's being swept from 300 Hz to 3 kHz at 50 millivolts. And I won't bore you to tears with the noise coming out, but suffice to say the peak-to-peak voltage coming out at this end is 5 volts peak-to-peak, so 20 log 5 V out over our V in, our 50 millivolts peak-to-peak, gives us our 34, say again, our 40 dB gain, which was the design criteria for the overall amplifier. So that's good, but as I just mentioned before, I do have the ability, once the rest of the radio is built, to tweak, and that should be in focus, to tweak that trim pot just here to give a variance in that driver stage to see where we go. Clearly there's a limit there to how much you can drive into the LM380 until that becomes saturated and you start to clip the signal. But like I say, that'll be the ability to give that a tweak. Not too much else to say there. It's again built on Vero board or strip board upside down. I normally have the 2 outer rows to be earth, and then one down from, normally as I look at it, the top side is the VCC rail, and once again that's the configuration I've used here. Again, just tacked down to our copper board here for mock-up before eventually being sent through to or being pulled down, stripped down, and then shoehorned into the Pelican case. Another change I've got on order, it was a good suggestion which I had sort of forgotten about and I couldn't find. Sorry about the reflections here, terrible. This LED, say again, this LCD here is a it requires a backlight to show the symbols, which in bright light, and I gave it a bit of a test, is not too bad, but certainly nowhere near as good as using a reflective or a transflective, I think it is, where it has both, system where it relies on light shining through and reflecting back through the LCD, which is much better for bright daylight. So I've got a couple of those on order, so hopefully that dimension there will be exactly the same. I think they are, which will allow me to swap it out, which will be good. So that's the only change since the last video. So like I say, I'll knock it on the head here. So it's, like I say, it's working well. I'm pretty happy with that. Really, it's simple. It's nothing spectacular there, so I'm not going to belabor the point here talking more about it. I'll say 73, and I will make a start on the, I think I'm sure on the list is the band pass filters. So we'll catch you next time. Cheers all.